Hello everyone and welcome to iXample. So in this video we are going to discuss about the file allocation and access in operating system. So before this video, if you haven't watched the video on file system, I will request you to please watch the video on file system so that you can get a better clarity on file allocation and access in operating system. So let's begin the topic. So how many types of file allocation methods are there? So file allocation methods are categorized into two parts. One is the contiguous allocation and other is the non-contiguous allocation. In the non-contiguous allocation, further it is divided into two branches, and one is the linked list allocation and other is the indexed allocation. So we have to read about three types of allocations here: contiguous allocation, linked list allocation, and the indexed allocation. So let's begin the discussion with the contiguous allocation. So as you can see in this image, this particular image will give an entire idea of what it is, what is the advantage and what are the disadvantage of this particular scheme. So first understand what is contiguous memory allocation. As the name suggests, everything will be in a continuous manner. So here, whatever file you are going to save in the memory, it will acquire the continuous blocks in the disk. Okay, and every particular block will be continuous till the file is being allocated fully. So suppose you want to assign some size to the file, some memory to the file. So if you start with the B size, okay, and if the block is of size B, you start with B, and if the size of the file goes up to N, so it will be B to N, B plus N minus 1. Okay, so you can just assume if you require N blocks, so how many allocations are needed and what will be the order of the blocks that will be allocated for the contiguous allocation. The directory entry, you have to make a directory entry. So there will be a memory, and to access that memory, you will have an index. Okay, and that index in the directory will contain three things. One will be the file name and where the file is going to start. What is the starting location? What is the starting address of the file? And what is the size? That is the length of the file. So length will be here the number of blocks that are required there. So for an example, as you can see in the first entry, file _1, that is the file 1. It is starting from 0. Okay, and it is having the size of 4. So how much it will acquire? 0, 1, 2, and 3. So the size will go up to B plus N minus 1. Okay, and here your B will be 0. So 0 plus 4 minus 1, that will be 3. So you can see in the memory area of the diagram, it is file 1 written over 0, 1, 2, and 3. So you will get an idea that, okay, directory system in the contiguous manner, if I start from 0 and the size is required of 4, I will go up to 3 and all will be in a continuous manner. So what is the advantage of this scheme? So this scheme looks very easy to implement. Once I have the allocation in the memory, I know that everything will be continuous. So it is very easy to understand. It is very faster to have the memory access because I know the start and I know the end. Okay, and this particular kind of feature can be accessed directly as well as in the sequential manner. And here the less disk movement is required. So when you, if you are aware of the memory movement, head movement are there. So whenever you want to access something, there is a head movement. So if everything is continuous, there will be less amount of disk head movement. Okay, and minimal seek time will be there. So these are the very good advantages of the contiguous allocation, but at the same time it comes with disadvantages. It comes with a very bad disadvantage, that is the wastage of memory space, as it suffers from both internal and external fragmentation. If you are not aware of the internal and external fragmentation, go and learn about these two things because these are very important topic of the operating system, and it suffers from both of these. So it is a very bad contiguous allocation. The file system has to be initialized at the time of the creation. So whenever you are going to create a file, you have to give the size of that file. And after that thing, you might not be able to increase the size, and many times you might end up in losing the amount of memory as unused. Okay, and here the file size cannot grow as it is pre-initialized because you must know the length. What is the length of a file? That is the size. So these are the advantages and disadvantages that comes with the contiguous allocation. Now coming to the linked allocation. What is linked allocation? So here you can see that each file is linked the list of a disk block. So here also the memory will be same only. Okay, there will be still the blocks and the numbering will still be the same, but here these allocation of the blocks will not be contiguous anymore, and these are scattered anywhere on the disk. So whenever we get any space and that space is going to be useful for us, we will just utilize it. Okay, and what will happen here, the directory will contain three things again: the file, the start, and the end. Okay, and every particular thing, suppose this is starting from 0. Okay, we will take this example to understand everything. We are starting from 0 and we are ending on 13. Okay, so how I will just go from 0 to 13 when I don't know the way in between? So what will happen here? I'll go to 0th location. The 0th location, the 0th block will contain the pointer to the next block that is occupied by the file. So after 0, you can see there is a pointer to 5th one. Then 5th will have the pointer to the next block, and then we will reach to 10, and then we will reach to 13. Once we reach to 13, we know that this is the end of our file allocation. So we will stop right there because it will have no further references. It will be null pointer that will be pointing to the block number 30. So this is the linked allocation of the file system. There are also some advantages and disadvantages associated with this. So here, what are the advantages? Advantages will be like better utilization of memory, because we are not just relying ourselves on the continuous manner. Wherever we find the block, we just get the memory allocated there only. It does not suffer from external fragmentation, but it do suffer from the internal fragmentation in long run. It use the free blocks and can be utilized for the block request. So whenever there is a block which is free, you can just request and get the free block for your file. The file can continue to grow and it does not have any constraint over the length. You should not be pre-allocating the size. So it is not the case where your file cannot grow. Your file can grow up till the memory is free. The directory contain only the starting block address. This is the feature. This is not an advantage. This is just a feature. The disadvantage is like it does not support the direct access. So if I want to have a direct access over a particular piece of block, I cannot have so, because everything is sequential. If I don't know the 10th one, I cannot know the 13th one. Okay, so memory required is here for the pointer storage as well. So there is an overhead of the memory required, which is due to the pointers. Error in pointer link can corrupt the entire file. So if there is any linkage error, it will corrupt your entire file because the references will get lost. Here every file block has to be traversed, so it is a sequential kind of manner, and it is slower than the contiguous allocation, as it can be easily seen that how it is being accessed. So it is relatively slow than the contiguous manner. After that thing, we have indexed allocation, the last one in the non-contiguous block. So in this scheme, it happens similarly. We have an index, and that particular index will have entries, and to whichever blocks we are allocated that file, that will be there. Here the discontinuous memory will be again happening. Here each file has its own index block, and the entries will be there in the particular block. Here in the directory, there will be only two attributes. One will be the file and the index block. And in the index block, everything, if you can see here, if 9 is our index block, it will contain the block of 1, 5, 10, and 14, which are actually the places where our files are getting stored. Okay, so here the indexed allocation is being there. You can see here what are the advantages. It utilizes the index block for efficient storage, and it supports both sequential and direct access. In the index one, we are having both sequential and the direct, but in the linked one, we were not having the direct access. Okay, it does not suffer from the external fragmentation. A bad file block does not fit the other block. So even if I lost in between the block number 5, the 1, 10, and 14 are still retained with me. I cannot lose anything out of it because I have an index which is going to map the blocks in the memory for that particular file. What are the disadvantages? So disadvantages are like there is insufficient in terms of the memory utilization, as you need extra block to have your memory block. Okay, that is for the index block. Pointer overhead is here greater than the links. As you can see here, we have to maintain 4 pointers at the same time in the index block. So the overhead is greater here. And for even for a very small file, we have to do all these entire steps. So if my block is like only 4 or 3 or 2, why I have to maintain the pointers and everything? I can use the contiguous or the linked one. So it is not so good when it comes to the small files, because it keep an entire block of keeping the index block. That is our overhead for the pointers. So this was all about the allocations in the file system. Now coming to the next topic. The next topic is the file access method. So file access method, how we're going to access the file. It can be sequential, it can be random. So in sequential, we have sequential file access, and in random, we have two kinds, that is indexed and the hashed file. So now first understand the sequential access. As the name is suggesting, sequential. So one by one it will be accessed. So sequential access is the access in which the records are accessed in some sequence. You have to follow some sequence, either +1 or +2 or directly the contiguous thing. So here the file is processed in an order, one record after the other. Okay, and this access method is most primitive one. From the day we started with the access in the file system, this is the one which come into the scenario. For an example, the compilers are using this sequential access only. You know that when you compile and when you submit your code for the compilation, it reads line by line. So what it is doing? It is doing a sequential access, and depending upon some flow, if there is any function call or anything like that, it follows that sequence only in which your code is being written. So your compilers, your interpreters, all these kinds of things, your assembler, these all softwares are using the sequential access. Now coming to the direct or random access. So what it is basically, so in random access or in direct access, you can access in any manner. You does not need to follow any particular kind of sequence. Here every record has its own address on the file, and with the help of it, which you can just directly access it for reading or writing. Okay, like an array we have indexed thing, no? So like the same only you can access the any particular thing on that particular file. Here the records need not to follow any sequence within the file, and they need not to be adjacent location on the storage medium. As you can see in the image as well, after one it is coming to, and where it is located at the fourth location, then the third, then the, so there is a very random and zigzag movements of things, so it does not follow any order at all. Then under this thing we had two things that were the index and the hash. So let's first understand the index one. So what it is doing basically, so this mechanism is built on the base of the sequential access. Like we had the sequential access, now we need to go to something else, that is the index one. So the base still is the sequential access. An index is created for each file which will contain pointer to various blocks, like we discussed in the file allocation thing, no? So we will again have a index based table where we will have the pointers to different for parts of our files, and here the index is searched sequentially as it is on the base of the sequential access, and the pointers are giving you the direct access to the particular file. So it is a combination where you are having the direct access, but it is at the end on the base of the sequential access only. So you can see here in the image, you have all the things records stored there in the page and the record manner, and you have the root, and on the top of the root you are having the indexes which are built on that thing, and you're going to access all the indexes in a sequential manner, and every particular index will give you the direct access to whatever the blocks they are pointing. Now the next one is the hashing. So hashed method is very new method, and it has been used very widely because it is the optimal way of performing the searches. Okay, so whenever you want the data, whenever you want to have the retrieval kind of thing, this is the best thing that it needs to do. Okay, so it increases the speed, better ease of transfer is there, improves the retrievals, optimizes the search of the data, and reduces the overhead of maintaining so many pointers. So thus the objective of hashing is to ultimately optimize the disk access and the packing intensity basically. So what you need to have here, the starting and the ending address of your file. Then you will apply some hashing algorithm, a logic up to like on the basis of which you are going to divide the memory, how you are going to access the addresses, and depending upon that thing you will access your entire memory based on that particular limit or the range of the address. Okay, so hashing is the latest way of file access method, and it is the best way to have the searches and the retrieval at the end. So this was all about the file allocation and the file access in the operating system. I hope you like this video and this was informative enough for your exam, which is IBPS or RRB IT officer. If you like this video, do hit the like button for giving us the motivation. If you are an unsubscribed user and watching this video, please do hit the subscribe button, and also stay tuned with us to get regular updates on different subjects that are relevant for your exam. We have our course running currently, which is for IBPS or RRB IT officer, which is providing video lessons, study notes, practice tests, live session, and the interview guidance. So you can just enroll now to get your preparation 50% faster, as it will be all given to you. You just have to study, and if there is any doubt, we are here to help you out.